So, what is time? I mean, it feels like the most real thing there is, right? It just flows. It moves forward. It carries us along. But what if that entire feeling, that deep intuition you have about time, is just a grand illusion? Well, today, we're going to tear that idea apart and then rebuild it from the ground up, using some of the wildest and most beautiful ideas in modern physics.
So, where are we headed? First, we'll look at the grand illusion of time that we all live inside. Then, we're going to pull back the curtain on a deep scandal at the heart of physics itself. From there, we'll dive into the absolutely mind-bending idea that time is born from what we don't know. We'll figure out why we remember the past, how that leads to a completely new way of thinking about gravity, and finally, we'll paint a new picture of the cosmos as this incredible interconnected universe of clocks.
Okay, so first things first, before we can break time, we have to understand the version of time that feels so real, the one we all just assume is true every single day. And you know who really nailed this idea? Isaac Newton. He basically pictured this one giant universal clock, a master timekeeper for the entire cosmos, just ticking away at a steady pace, completely separate from anything we do. And let's be honest, for hundreds of years, this is pretty much exactly how we've all felt time works. It just seems obvious.
But here's where it all starts to get really weird. This is the central conflict, the big mystery that kicks this whole thing off. You've got our experience on one side. Time only goes forward. You know, you break an egg, you can't unbreak it. We remember yesterday, but we have no memory of tomorrow. But then you look at the fundamental laws of physics, and they couldn't care less which way time is flowing.
And this brings us to what some physicists call the scandal of their field. It's this deep, nagging problem that they've been wrestling with for over a century. Our best, most successful theories of reality tell us that time shouldn't have a direction at all.
I mean, just look at these equations. These are the absolute pillars of physics, and they all share this shocking secret. They're time reversible. What does that mean? Well, it means if you recorded a planet orbiting a star and played the movie backwards, it would look completely normal. The physics works perfectly both ways. But you can't play a movie of an egg breaking backwards and have it make sense. You can't unstir milk from your coffee. This one-way street of time that we see everywhere is totally missing from our most fundamental rulebook. So, where does it come from?
And if you thought that was weird, hold on, because the rabbit hole goes deeper. This thing right here, this is the Wheeler-DeWitt equation. You can think of it as the master equation for the entire universe. Everything that is, was, or will be, all wrapped up in one place. But look closely. You'll see something is missing. There's no t. The variable for time, it's just not there.
So what this suggests is totally radical. That the universe, when you zoom all the way out and look at it as a whole, is fundamentally timeless. It's a static, frozen block where there is no past, present, or future. It all just is. So if that's the real bedrock of reality, where on earth does our powerful, undeniable feeling of time flowing forward actually come from?
Okay, this brings us to the grand revelation. The proposed answer is as shocking as it is elegant. Time isn't some fundamental feature of the universe. The theory says that time flows for you and me for one simple reason, because we're ignorant. Our incomplete view of the universe is what creates time itself.
Now, this core idea is called the thermal time hypothesis, but let's just use an analogy. Think about temperature. A single water molecule doesn't have a temperature, right? The idea of hot or cold only makes sense when you have billions and billions of them all bumping into each other. Temperature is an emergent property of the crowd. This hypothesis says time is exactly the same. It's not a property of the universe itself, but something that emerges from our blurry, fuzzy statistical interaction with the universe.
So how does our ignorance literally create time? Okay, let's walk through it. Because you and I can't know the exact state of every single particle in the cosmos, we have to describe things with averages and probabilities, what's called a statistical state. And here's the magic trick. It turns out that whenever you describe a system this way, a natural mathematical flow just pops out of the equations on its own. That flow, that's what we feel as time. Which means a hypothetical being who knew everything perfectly would see no time at all. They would just see that frozen, static reality we talked about earlier.
Okay, so our blurry vision creates the feeling of time passing. But that still doesn't tell us why it only flows in one direction. You know, why is it an arrow and not a two-way street? Why do we remember yesterday, but not tomorrow? Well, it turns out this whole model has a brilliant answer for that too.
The secret, it seems, goes all the way back to the beginning.
There's an idea called the past hypothesis, and it basically says our universe started out in this incredibly special, highly ordered state. Physicists call it low entropy. The best way to picture it is like a perfectly wound-up clock at the start of time. And that very special, pristine starting condition is the ultimate reason we experience time as a one-way street. But why does a neat and tidy beginning matter? Well, because any time you create a record of something, whether that's a fossil forming in rock, a picture being taken, or even just a memory forming in your brain, that physical process has to make the universe just a tiny bit more messy and disordered. It has to increase the total entropy. And you can only increase disorder if you start from a place of order. So the arrow of time we feel is just the direction the universe is moving as it gets messier. It's the only direction in which we can form records of the past at all.
All right, now we get to what is maybe the most powerful, most mind-blowing part of this whole idea. This theory of emergent time is so profound, it doesn't just explain our perception of reality, it might actually explain one of the fundamental forces of nature, gravity.
So back in 1995, a physicist named Ted Jacobson did this incredible thought experiment. He started with just a few basic rules from thermodynamics, the science of heat and information. He totally ignored everything we thought we knew about gravity, and just asked a simple question. If these basic rules about energy and disorder have to be true everywhere in the universe, what would happen?
And the result was just stunning. Out of these simple rules about heat, Albert Einstein's famous equations for gravity just appeared. They emerged naturally. This strongly suggests that gravity isn't a fundamental force at all. It might be an emergent effect, just like pressure. You know, one single atom doesn't have pressure, but put a trillion of them in a box and suddenly you get pressure. In the same way, gravity might just be the universe's way of balancing its books, thermodynamically speaking.
So let's put all these pieces together. If time is an illusion born from ignorance and gravity is just thermodynamics, what does this new version of reality actually look like?
Well, you can forget about Newton's single master clock for the whole universe. The new picture is more like a vast interconnected web of countless local clocks. Every single one of us, every observer, generates our own personal flow of time, simply because our view of reality is incomplete. And the only reason we all agree on what time it is because our blurry views of the same underlying reality cause all our little personal clocks to tick in almost perfect sync.
And here's one final, absolutely wild idea to leave you with. What if the arrow of time is really just a measure of the universe's growing computational complexity? The idea here is that the universe is essentially a giant quantum computer performing some impossibly vast calculation. And in this view, time flows forward for one simple reason. The calculation isn't finished yet.
So let's just quickly recap. We've seen that time probably isn't fundamental at all, but something that emerges from our own limited viewpoint. The arrow of time, that one-way street, comes from the very special way our universe began. We've even seen that gravity might not be a fundamental force, but just an effect of thermodynamics. And all of this paints a new picture of reality, not of one single time, but a cosmic web of countless personal, emergent clocks.
It's a total rewrite of our most basic ideas about reality, and it leaves us with one final, fascinating question to chew on. If the universe really is a computation, and time is just the sound of it running, you have to wonder, what is it calculating, and what happens when it finally finds the answer?